Okay, we can start. Uh, this the question is to compute the limit. So this is pretty basic. So you can start to say that this part here we can factorize, right? We can factorize 3 and -1, right? So we can set up, and this is also can be factorized, right? So we can set up the fractions and factorize. We can cancel this. And the rest is we can just directly substitute. Going here, going here. So it will be -6, -4 or 3 over 2. Okay. Okay, next questions. This is we have a limit, and we have the limits at infinity problem, which means we are going to approach the x to the infinite or negative infinity. So in our case here it's the negative infinity, and we are looking at our structure. So the first clue is to see the, if it is polynomial, we need to see the degree. So the highest degree for both of the numerator and the denominator is 4. Okay, it's 4. So basically, the shortcut, if you want to solve this, we can say that this is going to be 1 over 3. Okay, but if you would like to show the proof why it's 1 over 3, we can set up the limit, and we are going to define with the highest degree of the variable, which means it's x over with power of 4. So this is going to be and then we can take the limit for all and the whole thing here will be 0, right? So we can write that this is 1 over 3. Okay. Okay, now I will deal with these two questions at once. We have the same equations, same functions. The difference is the limits. Okay, the limits. So when we talk about when limits at close to infinity and close to negative infinity, we can imagine how the x behave. Okay, so if we look at this positive infinity, it means that x will goes through the right side. Like if we have the axis, this is going to be the positive infinity, and this will be going to be negative infinity. So if we have this, then the problem will be the square root. Okay, the square root. So when we have the square root, let's say x squared, okay, actually we will go by positive negative x, right? But when we have x is positive, we only take the positive one, and when x is negative, we take the negative one. Or we can actually write down as the x absolute value. So x is positive here, so we can take this into just x. Okay, which means if we take this limit at infinity and we want to to divide with the highest degree. The highest degree is just 1. This 1, right? And this is also 1 because of the square root, okay? Now we take that and we wrote that, and 2 and 6 over x, okay? So this will be and this will be 0, right? And this will be half. Okay, nothing too complicated here. But when we have the negative 1, okay, so we have x is negative. So the square root of x squared will be negative x, okay? So when we deal with the limit and we divide with the highest degree, so this is 1. And now we divide with this square root of x squared will be negative x, okay? Okay. So we are going to have let me write slowly here. So this will be negative 2 plus 6 over x. Okay, so this will be 0, 0, and we are going to have negative 1 over 2. So please be careful on the positive and negative when you deal with this kind of situations. And always remember that when you have the square root of some x squared or any polynomials degree inside, please be mindful of what we will have, okay? What the possibility we are going to have. This is actually we have the absolute value of x, right? It can be positive, it can be negative. It depends on the conditions, okay? Okay, we start with this question, and the moment you saw this square root here, we are going to conjugate this equations. Okay? So how to conjugate these equations? Basically, conjugate means if you have a square root minus with something or plus, then you need to multiply with the opposite versions. Okay, and let's do that. And remember that when we have the conjugation, the result should be if we have a plus b, and we need to multiply with this, then we need to get the a squared minus b squared like that. Okay. So when we have this, so basically we are going to square this and square this, right? So we are going to have square over here and square over here. So let's just multiply this with the conjugate. Okay, and then the same thing here. Okay, and then we have this becomes x squared plus 2x minus 1 and minus x squared. And then we have x squared plus 2x minus 1 minus x. Okay. So then what will happen? We have Canceling this, and we have 2x minus 1 over, oh, forgot to write the limit. So limit x infinity, and we're going to have, okay. Now remember, we have the x is going to the left, which means it's going to be in the negative side, right? So when you have an x in negative side, when we have x squared, this will become negative x, okay? So because we have these limits at infinity, we are going to look at the form and look at the degree. So we have degree 1 here, and the below we have also degree 1, which is symbolized by this and this, right? So let's try to divide all with 1 over square root of x squared like that, okay? So we are going to have, this will be negative x, okay? This will be negative x also. So negative x will be negative 2 and minus 1 over x, or plus, that's also okay. And here we have 1 plus 2 over x, and this will become minus. Okay, so after we divide with this 1 over the square root of x squared, which we have the negative x. So we have, this is negative 2 plus 1 over x, and then this is the inside here, and this negative x, it's become plus 1, okay, plus 1. So we take this as, this will be 0, 0, 0, so we will have negative 2 over 2, so we have negative 1, okay? All right. Okay, now we have the this limit. We have the cube root of x, and then sine 1 over absolute value of x. Okay. Now, to begin with, do not be intimidated by this sign. Okay? We always have a principle when we have sine. So when we have these signs, we always remember that sine will be in between negative 1 and 1 for its max and minimum value. Okay, so we could have multiply all of this with, so we multiply all of this with the cube root of x. So we have negative maybe let me make it a little bit in the middle here. Then, so we have sine and there. Okay, and then we take the limit as x goes to 0. And we are going to fulfill, or to have our limit. This becomes our principles. Because of this limit is equal to 0, then by squeeze theorem, this limit also zero. Okay, so nothing to worry about. The next is this limit. Okay. Maybe you are thinking to start with the this limit, its limits at infinity. Maybe you are thinking to give this sign another squeeze theorem. But we are going to have some difficulty with when we have here. Okay, let me just rewrite this first, okay? And let me give you a clue that we have, okay, when we have limit as x closer to 0. When we have this, we are going to have equal 1. Okay, let's say we are having t is 1 over x. Okay, that, well, t is like a dummy variable. And when x is going to 0, t is going to infinite, right? So we could have limit t equal to infinite, right? Of the sine 1 over t, 1 over t. And this will be equal 1. It's the same thing. It's the same thing, okay? Because we have this relations, we can make it become these two relations, right? We have sine x over x equal 1, we have sine 1 over t over 1 over t is equal 1, and we are having the sine of 1 over x, and we have x is going to infinite. It's perfectly similar to what we have here, okay? So we can try to manipulate our limit, okay? So first we could force out this sign. Let's take this and make it 1 over x. Okay? But then, if we make this, we need to also balance these equations by taking x here. Okay? So we can separate this limit. And the other one will be this sine 1 over x over 1 over x. Okay? This part is equal 1. So this is perfectly equal to just a normal limit at infinity. Okay, and then we can divide with the x, okay, with the x squared. Since it's positive, we don't need to worry about the positive negative signs, so we just need to divide all inside with the x squared. So this will be 2 plus 1 over x squared, and this is going to be 1. So we are going to have this part here will be 0, right? So we have a square root of 2. Okay. Okay, the next question is more analytical, and I think it should be easy if you follow my notes in the class. So there are at least three reasons why f is not differentiable. Okay, let me write here to give you some notes. Okay, so first is, of course, if you have discontinuity. Second, you have a tip corner, sharp tip corner. And the third one is if you have a vertical tangent. These three reasons is why you will not have a function that is going to be differentiable, okay, because of these three reasons. So let's dive into our graphs. So of course we see from the very first, from the left, we see this discontinuity. Okay? So this is 2, 3, this is -4. So when x equal -4, we say this is discontinuity. Okay, and then we see also this part here, which means we have a tip corner. And then we also have this. We have some asymptote, right? We have another discontinuity. We can write x equal to discontinuity. And then another one, this part here, is a vertical tangent. Okay? So x equal 5 is a vertical tangent. Okay. Okay. Okay, now we have this question. We have piecewise defined functions. So we have the functions when x is less than 0, we have this, okay, square root of negative x. And when it's between 0, includes 0, and less than 3, we have this. and when it's greater than 3, we have this. Okay, so we are going to evaluate the limit first. Okay, so this is the question 8. So first, we are going to evaluate limit x from the right. So from the right of the 0, we are going to look at the 3 minus x, right? So 3 minus x. So we have, this is 3. Okay. And then we have limit 0 from the left. From the left will be square root of negative x, which means it's at 0. Okay. So we don't have the limit. Okay. It doesn't exist. Okay. Because of this is not equal. Okay. Or you can write because or maybe I forgot the functions. Okay. Now the fourth question from A is limit from the left of 3. So 3 we have 3 minus x. So this will be 0. The fifth one, we have 3 from the right. We will have x minus 3 squared, which is equal to 0. So we have the same conclusions, which means we have limit is equal with this, and this also conclude that this will be equal to 0. Okay. Now where f discontinues? If we look at uh, the solutions here, the f is discontinuous at this 0. Okay, at this 0. If we take some time to sketch the graph also, so I will tackle this B and C with a single graph, so you can see the answer directly. Okay. Now we have a 0, so probably 0 here. So first is we have this. So the graph of square root of x is this, right? So the square root of negative x is reflections to y-axis, which means we have here. Sorry, it's bad graph. Okay, or yeah, probably like that. Maybe give a little bit smoother, like that. So this is square root of negative x, okay? And then it should not be included with the 0 there, okay? So I need to make that this is open interval. And then 3 minus x, 3 minus x. So 1, 2, 3. 3 is here, okay? And then it should be maybe 1 here. And then it's going to be here. More or less. Not really good. Maybe I make it too close. Let me just take this and combine this. Okay. Yeah, maybe this is okay. So this is 3 minus x, okay. 3 minus x, it should be open interval again. And then we have x minus 3 squared. Okay, x minus 3 squared. So we are going to have like that. This is just a regular x squared, but we move to the right side 3 units. Yeah, probably like that. Okay. So the discontinuity is, I think it discontinues at x equals 0 and x equals 3. Okay. Also, we can argue why x equals 3 is not exist, because f3 is not exist. Remember that the continuity we need to have, this is exists and we know the final limit, and this is equal to the function itself. Okay, this is the continuity. Okay. Okay. So this is because, okay, we can say that. Okay. All right.